Hello students, welcome to the review class of our chapter 1 science 1 that is gravitation. Okay, so हम ये रिवीजन वीडियो फिर से क्यों बना रहे हैं? बिकॉज ऑफ योर नेक्स्ट वीक क्लास टेस्ट और आपको क्लास टेस्ट में ये चैप्टर है, इसलिए we will study this chapter, the revision, we are going to do the revision of this chapter again. एंड इस वीडियो में मैंने जो भी रिड्यूस्ड सिलेबस है वो नहीं डाला है, वो कट किया है, एंड जो सिलेबस आपको है उसमें से मैंने मेन पॉइंट्स लिया है. ओके, एंड आई हैव टेकन सम एडिशनल इंफॉर्मेशन दैट आई विल टेल यू. एंड वन अनदर थिंग इज़ दैट टेक्स्ट बुक में जो भी सॉल्व्ड एंड अनसॉल्व्ड एग्जाम्पल है, प्रॉब्लम्स है, वो सब आपको है और उसमें से कुछ भी रिड्यूस नहीं हुआ है. सो यू हैव टू डू दैट. ओके, दैट आई हैव नॉट टेकन इन दिस वीडियो, वो कुछ भी रिड्यूस्ड नहीं हुआ है. ओके, तो उसका एक वीडियो मैंने अभी अटैच्ड किया है एंड बाकी के सम्स जो थे वो मैंने पहले ही सॉल्व करके दिया था जब हमारा ये चैप्टर चालू था, मे बी इन द मंथ ऑफ जून जुलाई. ओके, सो मेक श्योर दैट कि वो आप वीडियो आपने अभी तक नहीं देखा है तो आप देखें उसको, सम्स को और सॉल्व करें. ओके, and the another thing is that for this revision video you need text book. okay, अगर आपके पास है तो आप टेक्स्ट बुक के साथ ये वीडियो ज़रूर देखें. ओके, सो लेट्स स्टार्ट. yes, so you all know that gravitation force is a universal force which means what? It is applicable for all. okay, and it acts not only between the two objects on the earth but also between any two object in the universe. okay, तो I hope आपको ये ध्यान में आया होगा. Then we are going to see the next, that is gravitation. What is gravitation? okay, so here the phenomenon of gravitation was discovered by whom? Isaac Newton. okay, you all know that. Then he discovered the force by seeing an apple fall from a tree on the ground. okay, he discovered this force, gravitational force, by seeing an apple fall from a tree on a ground. Then he wondered that why all apple falls vertically downward, that is in the downward direction, why not in upward direction, or else why not it fly off in horizontal direction. So after much thought he came to the conclusion that the earth must be attracting an apple towards itself. okay, this is the earth, so earth must be attracting an apple towards itself, and this attractive force must be directed towards the center of the earth. okay, yes, so the direction from the apple on the tree to the center of the earth is a vertical direction. You can see this is the vertical direction. okay, at the position of apple, and thus the apple falls vertically downward direction. So here what this figure shows, this figure on the left side shows an apple tree on the earth. okay, this is apple tree on the earth. yes, so the force on an apple on the tree is towards the center of the earth. yes, so along the perpendicular from the position of apple to the surface of the earth. yes, so this figure also shows the gravitational force between the earth and moon. okay, here you can see moon and earth. so this showing a gravitational force between the earth and moon. okay, yes, so next आपको दिया है use of ICT. so that is not for your that is a reduced syllabus. okay, वो आपको नहीं है. then we are going to see force and motion. what is force and motion? Force is necessary to change the speed as well as the direction of motion of an object. okay, so if I want to change the speed as well as direction of motion of an object, then what I need force. okay, so force is necessary for that. yes, then circular motion and centripetal force. student ये जो part है ये आपको ये reduced किया है, but इसमें से डेफिनेशन ऑफ सेंट्रीपिटल फोर्स आ सकता है. सो दैट इज इम्पॉर्टेंट. ओके, द डेफिनेशन इज वेरी इंपॉर्टेंट. सो दैट इज व्हाई आई हैव टेकन दिस. ओके, आपको भी ये समझना है ताकि अगर एग्जाम में आया तो कुछ डिफिकल्टी नहीं होगी. ओके, सो what is circular motion and centripetal force? A force acts on any object moving along the circle and it is directed towards the center of the circle, then it is called as centripetal force. Here you can see force is applied from the center of the circle to rotate the string. Okay, here you can see force is applied from the center of the circle to rotate the string. So from center we are applying any force. So that is called as what? That is called as a centripetal force. Centripetal force, which means what? Center seeking. The object tries to go towards the center, here you can see, and towards the center of the circle because of this centripetal force. So you know that moon, which is a natural satellite of the earth, you all know that? Yes. So it goes round it in a definite orbit. The direction of motion of moon as well as its speed constantly changes during this motion. Okay, so you must have know that moon, to go around the earth there must be a force which is exerted on the moon. Yes, and this force must be exerted by the earth which attract the moon towards itself. Similarly, what happens? Sun is a central part of solar system. You all know that. So all the planets revolve around the sun. So sun, what sun does? It attracts the planet, including the sun, including earth, towards itself. So which force is applicable over here? That is a centripetal force. ओके, और एक बात जो आपको इंट्रोडक्शन टू साइंटिस्ट ये दिया है वो सब रिड्यूस्ड है. ओके, यस. नाउ नेक्स्ट इज केपलर्स लॉज ऑफ प्लैनेटरी मोशन. ओके, सो व्हाट इज दैट? Kepler's first law says the orbit of planet is an ellipse with sun at one of the foci. What is ellipse? An ellipse is a curve which is obtained when a cone is cut by an inclined plane. Okay, तो ये आपको पेज नंबर 3 पे दिया है टेक्स्ट बुक में. Just go through that, you will understood better. Okay, so according to Kepler's first law, here you can see the figure shows that the elliptical orbit of a planet. This is the elliptical orbit of a planet which is revolving around the sun. Sun is here and the position of sun is indicated by S. Here you can see. Okay, so this is the first law. Then according to second law, the line joining the planet and the sun sweeps equal areas in equal interval of time. So here you can see AB and CD. These are the distances of covered by the planet, A, B and CD. Okay, in equal time, after equal interval of time. The position of the planet starting from A and C, here A and C are shown by B and D, B and D, okay, respectively. So the straight line AS and CS, AS, where is S? Yes, AS and this CS, which sweeps equal area in a equal interval of time. Okay, so ASB and CSD, they are equal according to Kepler's second law. Okay, then what about Kepler's third law? The square of its period of revolution around the sun is directly proportional to the cube of mean distance of a planet from the sun. Okay, thus if r is average distance of a planet, here you can see, from the sun, and t is a period of revolution, then what we will get? T square upon r cube is equal to constant, that is equal to k. Okay, so this is very important, Kepler's third law. Okay, yes. Then next we are going to see a very important law, that is Newton's universal law of gravitation. It is very easy, you all know that. So according to this law, what happens? every object in the universe attract every other object with a definite force. Okay, yes, and this force is directly proportional to the product of the masses of the two objects, and it is inversely proportional to the square of distance between them. So from this what we will get, F is proportional to m1 m2 upon d square, or F is equal to G, that is what, G is gravitational constant, m1 m2 upon d square. Here m2 is there. Okay, yes, so m1 and m2, these are what, these are the masses of the two object, m2. Okay, d is what, distance between them, and G is what, universal gravitational constant. Okay, yes, here the above law means that if the mass of one object is double, then the force between the two objects also double, and also if the distance is double, then what happened, the force decreased by a factor of 4. Okay, if the two bodies are spherical, then the direction of force is always along the center of the two bodies. Here you can see. Okay, yes, and the distance between the center is taken by d. Okay, yeah, so in SI unit, the unit of G is what, Newton meter square kg raised to minus 2. In SI unit, its value is 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. ओके, तो ये MCQ के लिए बहुत इंपॉर्टेंट है, सो पे अटेंशन, यू हैव टू रिमेंबर दिस. देन the gravitational force is much weaker than other forces in the nature, but it controls the universe and decides its future. So this I have taken from page number 5. ओके, आपको यूनिफॉर्म सर्कुलर मोशन कैंसिल है, बट जो लास्ट पैराग्राफ है उसमें से 1 2 3 4 लाइन जो है वो 2-3 लाइन इंपॉर्टेंट है, सो आई हैव टेकन दैट. ओके, so this is possible because of what, huge masses of planet. So you all know that planet has huge masses, and this is possible because of that, and stars and other constituents of the universe. Okay, so this is about page till page number 5. देन पेज नंबर 6 में आपको सम्स है वो इम्पोर्टेंट है, वो करना है, एंड देन डू यू नो एंड यूज योर ब्रेन पावर, दैट इज कैंसिल. So now we are moving towards page number 7, that is Earth's gravitational force. Okay, so what is that? The Earth attracts every object near it towards itself because of the gravitational force. Okay, yes, the center of mass of Earth is situated at its center, so the gravitational force due to Earth is always directed towards the center of the Earth. You all know that. Okay, so because of this force, an object falls vertically downward on the Earth, and the gravitational force due to Earth also act on moon and artificial satellite. Okay, so here what happens, when we throw a stone vertically upward, this force tries to pull it down and reduces its velocity. Due to this constant downward pull, what happens, the velocity becomes 0 after a while, and the pull continues to be exerted, and the stones start moving in vertical downward direction under the towards the center of the Earth under its influence. So you all know that the gravitational force due to Earth is also act on moon and artificial satellite. Okay, yes, so then Earth's gravitational acceleration, page number 8. So here, according to Newton's second law of motion, the force acting on body results in its acceleration. Yes, thus the gravitational force due to the Earth on a body results in its acceleration. Okay, this is called as acceleration due to gravity, and it is denoted as small g. Okay, so acceleration is a vector quantity, which means what? It has both magnitude and direction. As the gravitational force on any object due to the Earth is directed towards the center of the Earth, the direction of acceleration due to gravitation is also directed towards the center of the Earth. That means vertically downward direction. So the unit of G in SI units is what? Meter per second square, and the value of G on the surface of the Earth is 9.77 मीटर पर सेकेंड स्क्वायर। इसका डेरिवेशन आपको पेज नंबर 8 पे दिया है, सो गो थ्रू दैट। ओके, यस, देन वेरिएशन इन द वैल्यू ऑफ जी। ओके, तो ये मैंने शॉर्ट करके दिया है, आपको पूरा वो पढ़ने का है। ओके, दिस इज़ ओनली फॉर योर रिमेंबरिंग, आपको अच्छे से ध्यान में रखने के लिए मैंने शॉर्ट करके दिया है। ओके, सो फर्स्ट इज चेंज अलोंग द सर्फेस ऑफ द अर्थ। द वैल्यू ऑफ जी इज हाइस्ट, that is 9.832 meter per second square at the poles, and the lowest, that is 9.78 meter per second square at the equator. Okay, so this change comes through along the surface of the earth. Then change with height. So as we go above the earth's surface, the value of r in equation, that is g is equal to small g is equal to gm upon r square, increases, and the value of g decreases. So sometimes what happens, the value of g is negligible. Okay, yes, then here the table is given on page number 9, which shows that change of g with height above the earth's surface. So this go through this once. Okay, change with depth. The value of g also changes if we go inside the earth, and the value of g decreases as we go deep inside the earth. Okay, you all know that every planet and satellite has different mass and radius. Okay, yeah, so on the moon it is about 1/6 of the volume of the earth. So as a result, using the same amount of force, we can jump 6 times higher on the moon as compared to that on the earth. So after that, mass and weight is given, that is a reduced syllabus, but just go through this. This is not a reduced, ये आपको self study के लिए दिया है, so आपको read करना है, mass and weight self study है. Okay, yes, then we are moving towards page number 11, that is things which is free fall. Okay, what is there in free fall? Okay, we all know that the force of gravity due to earth act on each and every object. Yes, when we are holding a stone in our hand, what happens, the stone was experiencing this force, but क्या होता है जब but it was balanced by a force that we are applying on it in opposite direction. जब हम हमारे हाथ में स्टोन पकड़ते हैं तो हमारे हाथ का फोर्स भी उस पर आ जाता है, एज अ रिजल्ट स्टोन रिमेन्स एट द रेस्ट. बट जब हम वो स्टोन रिलीज कर देते हैं, देन द ओनली फोर्स दैट एक्ट ऑन इट इज ग्रेविटेशनल फोर्स ऑफ द अर्थ. ओके, सो तभी क्या होता है, स्टोन फॉल होता है in downward direction into its influence. Okay, so whenever an object move under the influence of force of gravity alone, then it is said to be falling freely. The stone falls freely if we release the stone. Okay, so here in what happened, in free fall the initial velocity of an object is taken as 0, and it goes on increasing due to acceleration due to gravity of the earth. Okay, for free fall the initial velocity u is equal to 0 and a is equal to g. Thus the equation is written as, here you can see, we are going to put u is equal to 0 and u is equal to 0 and a is equal to g. Then in first equation we will get v is equal to gt. In second equation s is equal to half gt square, and in third equation we will get v square is equal to 2gs if we put this over in this equation. Okay, yes, so the moon and artificial satellite are moving only under the influence of gravitational field of the earth. So moon and earth, they are in free fall state. Okay, yes, then page number 13, gravitational potential energy. You all know that the energy stored in an object because of its position or state, then it is called as what? Potential energy. This energy increases as we go to higher heights from the surface of the earth. Okay, yes, the potential energy of mass m at a height h from the ground is taken as mgh, and on the ground it is 0. So for an object at infinite distance from the earth, the value of g is 0. Okay, You all know that when h, that is height, is small as compared to radius r of the earth, then we can assume g to be constant, that is acceleration due to gravity to be constant, and can use the formula that is mgh. Okay, yes. So, but for the large values of h, the value of g decreases with increase in h. Okay. For smaller distances, the potential energy is less than 0, that is, it is called as negative. So, when an object is at a height of h from the surface of the earth, its potential energy is written as minus of g m upon r plus h, where m and r are earth mass and radius respectively. Okay, m क्या है mass और r क्या है radius, h is what height. Okay, and capital G is what gravitational constant. Okay, then a very simple topic, that is escape velocity. So we have seen that when a ball is thrown upward direction, its velocity decreases because of the gravitation of the earth. So the velocity becomes 0 after reaching a certain height, and after that the stone starts falling down. Its maximum height depends upon what its initial velocity. Okay. Okay, so the higher the initial velocity u, higher is the height reached by ball, that I have taught to you. Okay, so we have seen about that the value of g keeps decreasing as we go to the higher above the surface of the earth. Thus, the force pulling the ball downward direction decreases as the ball goes up. So if we keep increasing the initial velocity of the ball, then what happened? It will reach to the larger and larger height. Yes, and above a particular value of initial velocity of the ball is able to overcome the downward pull by the earth, and it can escape from the earth forever, and it will not back on the earth. So this is called as escape velocity. In short, the velocity with which an object escape earth gravitational force and go and stop at infinity and will never come back, not come back, is called as what? Escape velocity. It gets escaped. Okay, so I have written here in short that the VESC, that is escape, is equal to रूट ऑफ 2gm अपॉन r. तो इसका डेरिवेशन आपको दिया है, वो आपको समझ के लेने का है. दैट इज़ वेरी इजी. ओके, एन ऑब्जेक्ट गोइंग वर्टिकली अपवर्ड फ्रॉम द सर्फेस ऑफ द अर्थ हैविंग एन इनिशियल वेलोसिटी इक्वल टू द एस्केप velocity. So the spacecraft which are sent to the moon or other planet have to have their initial velocity larger than the escape velocity, so that they can overcome the earth gravitational attraction and can travel to these objects. Okay, so this is all about your chapter 1. Go through this because this will come in your exam, upcoming exam, that is your class test. Okay, so this is all about today. Go through this video, watch it again and again. Okay, thank you.